Hey, what's up, Quentin?
Hey, Jeremy, not much.
Nice.
Yep, just the work. Almost done.
Nice, man. That's good.
Yeah.
Man, well, you're almost done this semester, man.
Dang, it's a miracle.
Yeah. Yeah, I feel it too.
So
Can't
our
wait to be.
semester opens on Monday, is that right?
Oh, what was that, my man?
Our exam opens on Monday, right?
I believe so. I'd actually have to check. I thought it said the 17th. Maybe it is Monday. I think you might be right. Let me double check.
Hello,
Hello, hello. Hey, how's it going?
I'm great. I'm right now
Awesome.
driving, so I'm back to home. So I'll be here just hearing.
Hey, that's not a problem, my man.
Is
Yeah,
that
No worries.
I
oh
haven't
the
reached home yet.
inmates?
Oh yeah, where they pick the potatoes.
Yep. You welcome back.
Let's see, exam.
Is there any sign for the first one, please?
Well, that must suck.
Yeah, you're right. It opens on the Monday. Intense. There you go.
Se puede conectar ahí.
Ends on Wednesday. All right. I'm just gonna try to invite everybody else. Just a sec, guys.
Mm. ¿Cómo se llama el carro? LGBT.
Okay. There we go. Just a sec.
Hello.
Hey, how's it going, Wendy?
Good, how are you?
Doing good. All right. I guess we are all practically here. We're just waiting on Kim.
Okay.
And then, well, there we go. Just gonna invite her once again. See if she comes. There we go. Let's give her a text message. Okay. Well, everybody, welcome. This is actually going to be our, I think this will be our last meeting. That's intense.
Mm-hmm. That's crazy.
We're almost done. It's a couple more days and then that's it.
Mm-hmm.
I think actually I was looking, I think the project actually, it's due on the 14th week. So actually give us a little bit time. So yeah, Kim actually just gave me a text. She'll be on soon. So what would you guys like to talk about? I mean, we could either, I'm pretty sure everybody's knows what to do for their part of the project, so we don't need to cover that. But is there anything, I guess, through anything of the homework at all? I know we didn't really necessarily have homework, just but the quiz. So we can kind of just start off doing that if you guys would be okay with that. I guess you guys down with doing that?
Yeah, I'm good with that.
All right, we'll just head right into it. We'll go head into the 47 questions. So much fun.
Mm-hmm.
All right. I'm just gonna open it up right now. Okay.
Could you please type the answers as Clinton did in the last meeting?
Oh, what was that, Styler? Sorry.
I just asking to Clinton, maybe he could type in the chat.
Yeah, not a problem, man.
That would be great because I'm still driving back home, and so I can check like the answers
Hi.
with mine. So
Hey, what's up, Kim? Yeah, not a problem, Styler. We can definitely do that. I'll try to do. Oh. Yep, no worries,
yeah,
man.
that would be great.
Perfect. All right, well, guys, we're all here. So we're actually going to start off doing the quiz right now.
Okay.
So we'll just open that up. I mean, if you guys have any other questions regarding like homework and stuff, feel free.
Before we start the quiz, I just finished the presentation.
Oh, you
So-
finished the presentation. Wow, okay.
Yeah. It's not really
Okay.
perfect, but so I
Yeah.
did it that the Clinton sent through the email.
Awesome, okay. All right, let me double check. Because actually, we were going to talk to you, actually, Kim. We actually assigned, well, last time, but that's great that you did it. That's great. Because we actually assigned each other a different part, just to make sure that everything was a little organized. But if you did it, then I guess what we can do is I can just probably take a look, and then we all can kind of check it out
Okay.
right now. All right. So let me see. So to check out the link again. There it is. So I guess did everybody open it up or?
Yeah, I have it open over here.
Awesome. All right. Well, good job, Kim. Actually, I wasn't anticipating for you to get it all done. That's
Thank
awesome.
you.
Good job.
Did I miss anything of them?
Slide 7 needs a title, is all that I'm seeing so far. But it looks really, really good.
Thank you.
Yeah, actually, yeah, it looks really good, for sure. Population students showing elementary school ages over 2. Actually, Kim, the only thing I guess I would change, I actually should send you an email regarding this, is just for slide number 3. So we actually did, hold up, I have to check actually. I might even send you the email with the updated design the study. So actually everything's been updated. I might just send that to you. Just because I think it's actually, we've done a cluster sample rather than, so yeah, it's kind of a little, the professor said it made sense. So I'm going to go off of that, what he basically indicated, but it is a random sample, but it's from a random sample that we have selected through a cluster sample. So it's like combined it into like two into one. So I'll actually even send that to you right now. So that's the only thing I can kind of see that could be changed a little bit. But other than that, it seems pretty good.
So I should change it to cluster sampling, right?
Yeah, that's right. I'll actually even send you the design study just to kind of clarify different things. But I'm looking through it right now. I just opened it up. So Yeah, so the sample method that we have chosen for our group is cluster sampling. The way we will collect the data is by selecting, so it's everything that you just stated in that. And I'll send it to you so you can actually see it right now.
Okay.
Just a sec. I have like a ton of windows open right now, so just bear with me.
Okay.
I'm just gonna see if that's the right one. Just gonna see if I got the right email. There we go. So you should have received it right about now. So I just sent it to you right now.
Yeah, I got it.
Awesome. And I'll actually go to share right here so you can kind of see my screen. There we go. This part right here.
Mm-hmm.
So if you actually go down to, so yeah, just right there. So I just changed it. The method that we have chosen for our group is cluster sampling. So that's the only change right there. That needs to be changed right there.
Oh, I see.
Yeah, and the way we will collect our data. And I guess the only thing is that I know that for yours, if I go back here, I did have a window of yours open. But maybe something to include in the design study is something I did kind of add right here, is that I stated that in our study, we wanted to determine if the overall population of students who eat fish sandwiches is less than 20%. This study will help us determine if schools should be. So what I did is actually in the study for the question, I just basically included that. So maybe something you might include is that in our study, in our study, we want to determine if the overall population of students who eat fish sandwiches is less than 20%. So that's pretty much what we are trying to determine right there. If that makes sense. Oh, sorry about that.
Okay, can you explain one more time? I'm
Yep.
sorry.
Not a problem. Just a sec. I'm trying to organize my windows up.
Okay.
Got like so many up right now. Kind of being a little disorganized. Hold on. There we go. Let's get rid of that. Let's get rid of that. Okay. So this will I'm going to make it easier for us to see. There we go. Let's go to design the study. Where the heck is that? Okay, there we go. And then I want to open up that right there. Perfect. All right, now I'll go to share so that you can kind of see what I'm looking at right now. Dang it. There we go. Well, that sort of solves it a little bit. Perfect. That makes it easier. So I guess the only thing I would kind of include is I know that for when you put for the design study, we're trying to determine the percentage of students who eat fish sandwiches. So the only thing that I would kind of include there is that in our study, we are trying to determine the overall population of students who eat fish sandwiches if it's less than 20%. So that's the only thing that I would suggest right here.
Oh, okay.
Yeah, sorry about that. There you go. Yeah.
Less than. Okay, I'll change it later.
Yeah, not a problem. And then overall on that, I think everything's pretty good. But anyways, we'll probably if I do think of anything else, I'll definitely inform you, Kim.
Yeah.
For sure.
Thank you about that.
No problem. But did you have any other questions regarding it all, or?
Not really.
Yeah. Okay. You did great. If a portion of each image is less, yeah, that's fantastic. That's great.
But
Good
I
job.
don't know how to submit this after I finished it.
Yeah, that's a good question. Clinton may be able to help you with that because he is the one that kind of he kind of organized it right there. He has a little bit
Okay.
more expertise in that.
Okay.
All right. Clinton, do you know what? Actually, Clinton, are you there, my man?
I think he's not.
Yeah? Okay. Hold up.
I think you can file download as a PowerPoint. Can you just submit the PowerPoint?
Okay.
Yeah. I'm going to actually see. Maybe I can see background plus. All right. We're trying to see if we can download this. All right.
Oh yeah. I
Oh, you figured it out? Awesome. Perfect. Wonderful. That's great. Okay. Well, I guess other than that, Kim, are you good or?
Mhm.
Yeah, awesome.
Yeah, I'm good.
Yeah, but if you have any questions, just let me know, and also let any of us know for sure. But I guess when
Okay.
you look, when do you think everything is good too, right?
Yeah, I just glimpsed through it all. I didn't read it all in detail, but it looks good. It looks there. I will look at it closer later. But you know what I mean? Like I just in the 5 minutes breezing through it looks like it's all there.
Yeah, okay.
Yeah.
If you guys find anything wrong, please tell me.
Yeah, we'll do
For sure.
Yeah.
For sure.
We're not going to just leave you in the wind.
Yeah.
Okay.
Number 7 needs a title. Probably is that that's just the data, right?
Mhm.
Okay. That or just we can delete that text box, can't you? I'm not sure. Whichever one you want to do.
Oh, it's not clicking, eh? Maybe it's because I'm actually on it. Hold up just a sec. I'm gonna like X out of it. Hold up. There we go. All right. Well, I guess, guys, other than that, did you guys want to go ahead up? We'll just hit up the quiz right now.
Yeah.
Awesome. All right. Let's do that. So I'll actually be honest. I actually started it already. So
Okay.
I kind of understand what's going on. So I was able to kind of go through the questions. So some of them I didn't understand, but hopefully you can help each other out.
I'm happy to hear that because I started and I got to like question 7. I started like a half hour ago, to be honest with you, so it wasn't. I didn't get too far in my.
Yep, no worries. I'm hoping that I have the right correct answers. We'll see. All right. Actually, you know what? I may even share this. I'll actually open it up, so you guys can take a look. Make it easier for you guys. You guys can see that now, right?
Mhm.
Awesome. All right. There we go. All right. I guess we'll start off with question number 2. All right. So which of the following variables are quantitative? Mark all that apply. the number of people in a random selected classroom. Sorry, yeah, that's what I put. So the telephone number of randomly selected business in town, the 3 most common brands of car found in the U.S., the number of people in a randomly selected classroom on campus. So I just put it as the third one.
The
But
number of
again-
people. Right?
Yep, the number of people, yeah. That's what I put right there. But it does give you an option to select more. I don't think the 3 common brands of a car found in the United States, I don't think that would work. And it just says the telephone number of randomly selected business in town. But that number, it's subjective because that number is not like, you can't measure it, right? You can't take a ruler and actually measure that number, right? So that number is just dependent upon businesses and towns. So I think it would just be the third one. All right, who would like to read the next one?
I'll do it.
Awesome.
Students in an introductory statistics class at BYU Idaho were studying prices of cold cereal at grocery stores in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left of the top shelf they would start on. They then recorded even 6 cereal afterwards, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is this study an experiment or an observational study, and why?
All right. So you guys can briefly look through that. I'm pretty sure it's the second one. I could be wrong.
I agree with you that I think it's an observational study. I just don't know. I thought it was the first one because they didn't know which cereal they were going to select. Because
Yeah.
after they selected, then they chose the price. But I don't. That's just where I was going with that.
Yeah, that is true. And that's pretty much like where I'm kind of confused a little bit too. Because like you're right, because like they don't have control. Well, maybe they do. Just because they're picking every 6th, right? So they do actually have control, that they're actually selecting those different packages of cereals. But you could be correct too in the other way too, is that, you know, that they don't really, because they can't pick the brand that they want to, right?
Right.
Which makes sense. Yeah, the only reason why I picked the second one. So it's either the first one or the second one. That's what we got. It's either, what I put it is for, I put it for the second one just because students had no control over the price of the individual cereals. So despite that they picked any of them, they wouldn't be able to, you know, specifically pick what price the cereal that they're going for. So that's pretty much what I put for that one. But otherwise than that, you guys can distinguish which one is right. There you go. Okay, so question number 4.
I got that one for you.
Awesome.
For a math 221 project, one group of students study the age of students on the BYU campus. They collect data from a random sample of 100 students. The sample mean is 21.2, and the sample standard deviation is 2.61. There's the data in that is in that graph below. The group notices an error in their data. The age of one of the males, ID number 3, was entered incorrectly. He's actually 21 years old. When the error is corrected, what will happen to the sample mean? I put that it will increase.
Will it increase?
Because that will no longer be so far out, so that the mean would get a little higher.
Yeah, I mean, I'm thinking it would stay the same. Like just because, for instance, if you kind of put, let's say you put 18, you put 12. Actually, I'm gonna write this down. Let me check this out again. I just think that it would stay the same because like if you put 18. And then you put 12, which is the first set of data. Then you put 18. no, sorry, 18, because 12 was actually changed to 21. So you would put 18, then you would put 21, and then you put 21, and then it would be, sorry, it would be, I'm just writing this around incorrectly right now. But just gonna write it down quickly. 25. Because the one that we're trying to look at is that you see how there's two 21s right here?
Mm-hmm.
So basically the two 21s, it's still calculated as 1, 2, 3, 4, 5, right? So when you're trying to find the medium, right, it's actually in the in-between number, right? So the mean for, so if you had 12, and then you put 18, and then you put 21, and you put 20 and 25, the middle would be 21, right?
Mm-hmm.
So just, and then
But
since you're changing,
because there's going to be 99 IDs, and just in the group of 99, if you take 12 away from the very beginning, I would assume it would increase.
oh, okay, I see. Okay, all right.
But that's me. I don't know. Kim, what do you think?
I don't know. I'm trying to figure it out. But...
Oh, okay.
Let me, actually, I'm gonna I'll show you. Let's go back here. Because if we had 18, well, I'm not in the editing yet. Let's go here, actually. Interesting. No, hold up. Yeah, that's right. 1, 2, 3, 4, 5. Well, I'm not. I think you are maybe right, Kim, or it might be the other one.
Okay.
So we will see how that one.
Yeah.
All right, we will move on to the next one. All right, and I'll go for it. All right, the time to complete a standard exam in BYU, Idaho, testing center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, and 99.7 rule, approximately what percentage of students will complete the exam under 50 minutes? Give your answer accurate to one decimal place. So for this one, I actually got 2.5. And I'm just gonna have to think about how I did that. Hold on just a sec.
No, I think you're right with 2.5.
Yeah, okay. Because I think what I did is I did 95 divided by 2, which gives you 47.5, and you actually take away that from 50, right? Because that's half of the, sorry, because in total for the rule, right, it's actually 100%.
Mm-hmm.
Yeah, so you just do 95 divided by 2, which gives you half of the actual, the graph. And then from that, you would take away from 50, and you get 2.5.
Yes.
But Yeah, awesome. All right, I'm glad I got that right. Sweet. All right, moving on to the next one. All right, the scores on the, oh, who would like to, which one of you guys would like to read it off?
I'll do that.
Awesome.
The scores on the LSAT are approximately normal with a mean of 150.7 and a standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum SAT score of 157 for admission. Find the 35th percentile of the LSAT scores. Give your answers occur to one decimal place. Use the applet.
Let's see. So did you guys end up getting this answer right here? Just let me know.
This is going back to the beginning of the semester, and I just don't remember that stuff.
Yeah, I had to actually review it. I had to go all over and look it over again.
Yeah.
Actually, I might be able to find a video for you. Just a sec. I'm just gonna have to exit out of sharing screen for a sec.
Oh, you're okay.
All right. Actually, I'll go back. Let's open this up again. There you go. You guys see the video right there?
Yeah.
Yep, that's the one you're trying to look for. This will help you out. So it's actually just in lesson number 5, and it's just the second part right here.
Okay.
And I can kind of show you guys, I mean, I can tell you how I got it just by showing you. Let's see, let's go back to quiz over here. So what it's asking you is it's asking you for the 35th percentile. So what you want to do is you actually want to find the Z score for this one. So you want to do is you want to go to anomaly probability applet, and you want to enter in the area right here for the percentage. And then as soon as that happens, you actually will get the Z score right here, which is negative 0.385. Just one thing to take in consideration is that right here is actually the 50 mark, right? So anything that you basically go over will actually be like 60% over, right? For instance, if you're trying to find the 60% for instance, like the 60% percentile, right? The number that you would go for is actually, you're going to have to go for the positive right here, right? So that's one thing to take in consideration. But you just basically enter in the percentile right here. You'd get the z-score. And then with the formula that is shown right here, which is x equals the mean population plus z-score times by the standard deviation. And that will actually give you the answer. I mean, if you guys have another method of doing it, I'm definitely down for explanation. But I'm thinking that's the right way of doing it.
That makes sense. What did you get on this one? I'm just going to write it down. I'm going to come back to it.
Yep, not a problem. So what I got is 146.8. I'm hoping that's right.
Right. Okay.
All right. So I guess we'll move on to the next one.
Yeah. I got that one.
Way cool.
A team of dermatologists study skin cancer among 60 to 70-year-old American men. Suppose you were part of the research team and took a sample of men from this age group and calculated their mean number of skin cancer spots in the sample. Also, suppose that if it is known that this distribution of the number of cancer spots is right skewed. Suppose the sample size of the study is 2. What would be the shape of the distribution of the sample mean? And I put skewed right just because it was skewed right before, but it's only 2, so then it's like I'm not 100% sure. Because there's not enough data to make it skewed at that point.
Yeah, exactly. I mean, that's pretty much what I'm thinking too. I mean, I remember seeing a similar question like this beforehand, and I think that was to do with basically if there was a lower sample size, and that would be right skewed. So I kind of remember reading that in the textbook. I'm probably going to have to review it over again, but I'm pretty sure that's the right answer. I could be wrong again, though. All right. So I guess we'll move on to the next one. All right, I'll go for it. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with a mean of population of 8,544 gallons and a standard deviation of 12 gallons. Suppose that a simple random sample of n equals 20 tanks is selected and the sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to this sample mean? So is asking for the z-score. So this is the answer I got right here. Yeah, and this is going way back again. So
I did get that one too.
Yeah, you got that same number too?
Yeah, I got that same number.
Awesome. All right, that's good. Okay. Moving on to the next one. All right. And Wendy, would you like to read that one?
Yeah.
Awesome.
What is? Oh.
Oh, go for it. Sorry.
What is the probability that the sample mean capacity of 50 random selected tankers will be greater than 8,540 gallons? Round your answer to 3 decimal places.
All right, now I'm gonna have to think. Okay. I'm just gonna double check my answer again. I remember doing it. Just gotta figure out how I did it before. Okay.
Did you use the applet for this one?
Yeah.
Did
Yeah.
we put,
So
do
that's
we
what
put
you.
the z-score in the applet?
Yep, that's what you would do. Yeah.
2.236. 2.236. And then,
Actually, even I'll be able to show you guys the actual equation. Might help you guys out. This one actually doesn't have the equation. So I think it's number 6. Yeah, that's the equation right there.
is it the z minus mu divided by the standard deviation and then the square divided by the square root of n?
Yep, that would be it.
Okay. Then I was using, of course they can't use the same numbers as the question before. I was like, wait, that's the same. No, it's not. It's the same equation, but it's
Yeah,
not
well,
the
looks very similar.
Yeah. Okay, let's see. Did you get a negative z-score?
Yes, I did, yeah.
Okay.
There we go. So then it would just be this divided by that. Let's give you that number right there.
Yeah. Did you get 90.991? I got
Yep.
way too high. Okay.
Hold up, if I go back. I'm pretty sure that's what I got. I really got to get rid of some windows right here. Where the heck did I put the quiz? And I'll be right back. Jeez. Dang. Can't believe I lost it. I think I just X'd out of it.
Oh no.
Yeah. All right. We're good. Yep, that's what I got. So I got that in the normal probability applet.
Perfect.
Yeah. All right. So now we're good at that one. Awesome. Okay. Okay, which of the following best describes the notion of the the significance level of a hypotenuse test? The probability of obtaining a test statistic at least extreme is the one you calculated, assuming that the null hypotenuse is true. The probability of a type 1 error, the probability of a type 2 error, the probability of rejecting the null hypothesis whether it's true or not. So let's see.
I think
it
I remember
is.
that this one is the type 1 error.
Yeah, I believe so.
Okay,
Actually,
on level or lesson 9 recap, it says the level of significance is a standard of determining whether or not the null whatever that thing would be rejected.
that's the knowledge of an example. Adults. The point is committed assuming that the null hypotenuse.
Was it the last one?
That's a good question. I think it would be type 1 is committed when we reject the null hypotenuse. That is reality true. Let me read the question again. Which of the following best describes the notion of the significance of a hypotenuse test? So you're thinking it'd be this one right here.
The bottom one.
Oh, the second one.
All the way down, one more.
Oh, the probability of rejecting whether it's not they're true. Yeah, they are making this question tricky.
The standard for determining whether the.
I'm still thinking it would actually be type 1 error.
Yeah.
Okay. I have type 1 error is committed when we reject the null hypotenuse that is really true.
I committed when a job applies that is in reality true. Yeah.
But the level of significance is a standard of determining whether or not the null hypotenuse should be rejected.
Yeah, I guess that does make sense. Well, you guys choose the best one and we'll see what happens.
Okay.
All right. Okay. So this one actually was question number 11. I read it. This one actually is a little bit, it got me stumped a little bit. But, all right. I'll go ahead and I'll read it for you guys. The heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. The sample was taken of N85 young adult females at BYU, Idaho, and the mean was computed to be a sample size of 65.4 inches. Which of the following explanations describes the correct way to interpret the 95 convenience interval for this problem? So this one I've always kind of gotten not necessarily right a lot of the times. But what I'm thinking is actually it'd be the two last ones and it would be the first one. What do you guys think?
You think it's the top two? Is that what you said?
So I think it's the bottom two and then the top first one. Yeah, I think there's a 95 chance that the true mean height of adult females in the United States is our convenience interval. And then, yeah, this is the bottom two and then the top one, yeah.
I think it's the last one.
I think the only bottom two are right.
Oh, hey, more than one.
Yeah, that's what makes it harder. So is it 3, is it 2, or is it 1?
Yeah.
That's right. Well, I guess I'll leave that up to your guys' discretion.
Yeah.
All right. Okay. So do you find me sharing the screen actually helps out, or?
I'm sorry?
Oh, do you guys find that the screen's helping out with me sharing, or are you guys not, or is this not?
I am looking at it,
Yeah?
kind of.
Okay, good. All right. Legit. No worries. Yeah, it just kind of, my computer's kind of being a little slow, which is okay. It's not a problem. No worries. All right. An investor with a stock portfolio worth several $100,000 issued his broker and brokerage firm because he felt that the lack of dissatisfaction, whatever, in the portfolio led to poor performance for many years. I know how to say the word, but unfortunately I can't pronounce it. All right, led to the poor performance of many years in a row. In an effort to avoid closed public scrutiny from the firm, agreed to settle with a conflict of abbreviation panel. The aberration panel compared a sample of 39 months of the investor's return with the average of the Standard and Poor 500 stock index, the sample period, in order to determine whether there was a substantial decrease. The data are recorded rates of return. The SAP has a known population mean of 0.95. Suppose you are a member of the aberration panel. Conduct a hypotenuse test to determine if the investor's portfolio performed significantly worse than the performance of the S&P 500, use a level of significance of 0.05. What is the p-value for this test? Wow, that was long. All right.
But did we do the question 12?
No, we skipped it.
Yeah, we completely skipped it. We can definitely.
Yeah.
All right.
I'm sorry.
No worries. All right. I guess. Do you want me to read it, or you get just the?
Okay, I'll read it.
Okay. Awesome.
Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation of weights of male beluga whales equals 125 kg, and the researchers feel comfortable using this standard deviation for their confidence interval. Are the requirements for the use of a confidence interval met? Explain.
So for this one, I put the second one.
Yeah.
All right. You're good with that one, right, Wendy?
Yeah, I'm good
Yep.
with both.
Awesome. All right, guys. You guys want me to read that over again, eh? You're good? All right, sweet.
On this next p-value one, oh, hey, that's why. I'm like, why am I not? I'm missing a step. Hello, I needed to open the data.
Yeah, no worries.
Did you just get its p-value from the Excel spreadsheet?
Yep, that's
Did you
exactly it.
calculate it? Okay.
Yep. I'm just trying to figure out how I did it last time. So compare the investor's average return per sample period to determine whether it's substantially decreased. So meaning that's less than.
Mm-hmm.
Actually, I may have to think about this again. What? Oh, okay. I don't even know if I'm using the right data. Hold up. Okay, I see. Okay, okay, okay. There we go. So what did you guys did sort of, I'm hoping that's the right answer, but I'm pretty sure it is. What did you guys get for that one?
Okay, so the null is it at 0.05?
Yes. So what it's saying is that the known population mean is 0.95. Yeah, and the level significance is 0.05. So what I'm thinking you do is actually you gotta put in the mean of return, so which is basically the null right here. And then from that, you're trying to see whether there was a substantial decrease, right?
Mm-hmm.
So then the type of test would be less than.
Okay.
I'm thinking. I hope I'm right.
See, so because like my p-value is 0.118, but if I put like on the top in the statistics, if I put, because it says the S&P has a known population mean return of 0.95, so at the top I put 0.95 in the mean, like that put the p-value of 8.22.
Oh, if you want to, would you like? You actually could show me that if you want to. Need to help you out.
Okay.
Yeah.
The problem is I'm on my phone for my Zoom or for my Google Hangout, and then I'm on my computer for the other because I can't. The computer didn't work the first time. I just have never tried it again.
Yep, not a problem then. Okay. Actually, I know that the computer we're using Google Chrome.
Yeah.
Yeah. So actually, Google Chrome actually will block you. So if you use Internet Explorer, it might be better for you. It might work. You can try that.
Okay, let me.
If not, then I'll try to explain through.
No, we'll just explain how you put. So you put your data in there. I got my data in there. It's the one from the rates and return. And then in the top box in the mean, you didn't put anything there. That's blank.
Oh yeah. So these remain blank.
Okay.
I'm not completely sure why. I just know that we've never used them before.
Okay.
Yeah.
I just had put in 0.95 in the mean because it was stated in the problem.
Yeah, that would make sense. Yeah, but I know that any time that we've actually entered the mean in, I think we've always put it in for the because what they're trying to do is that the S&P has a known population mean, which is 0.95. I think that you're actually trying to determine if it's actually less than that.
Okay.
Panel, so 39 returns average standard for same period in order to determine whether there's substantial decrease. Yeah, so you're actually trying to determine if there's less of a return than 0.95.
Okay, so then going down from there, the first one that you filled in was the confidence level, and you put in 0.35 there.
Yeah, so pretty much what I did is that for the confidence interval right here, I put in at 0.95 just because we have a level of significance of 0.05. And then for the null, it would be 0.95 just because the mean actually is 0.95. And as you enter all of that data in, you should basically come up with a p-value of that one right there. And the reason I did less than It's because we're trying to look for whether there was a substantial decrease right here.
Okay. Yeah, I have the same p-value now.
Yep. Awesome.
Yeah.
I'm pretty sure that's the right answer. I'm hoping.
Okay.
Yeah. All right.
Perfect.
Awesome. All right, and I'll go for number 14. A financial. Oh, sorry, Kim. You got that one too, right, Kim?
Okay.
Oh, sorry.
No.
Oh, I meant the question beforehand.
Oh, right.
Yeah, you got that one, right?
Yeah.
Yeah. Okay. Awesome. Okay, you go for it.
The financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why? Independent sampling, how he selects the husband is independent of how he selects the wife. Dependent sampling, he needs to select couples for his sample, so whether a particular wife is included depends on whether her husband is. I think this is right, the second one.
Yeah. I think it would be the second one too.
Yeah, I agree.
All right. Awesome. I can read the long one if you guys want me to.
Okay.
All right.
You've got.
Pressure. If you guys, it's up to you. We can read every single one, or do you guys just kind of read it through yourselves? Because I know we have like 47 questions. So, what would you guys like to do?
Yeah.
You guys okay still reading through it, I guess, or?
Yeah, let's just read through it.
Okay.
We'll get there.
All right. Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If the seats on the flight do not sell well on an airline, may discount the tickets or even cancel the flight. Ali Henrich, a BYU Idaho student, wanted to determine if there's a difference in the price of tickets listed 90 days before the flight compared with 14 days before the same flight. For her study, she compared the prices of one-way flights from London Heathrow Airport to various destinations in Europe. Using the Travelicity.com, she recorded the low published fares of 90 non-stop midway flights, 90 days in. Hold that 90 days advance, then found the lowest published price for the same destination again, 14 days in advance. The prices in United States dollars are given in the file. Notice that there are some destinations flights were not available. All right. So for this one, I believe you'd use a paired sample t-test.
I think you're right.
Just because we're trying to compare the same flights, so they're similar, and we're comparing them both. I believe that's right. I believe it's right. Hopefully.
Yo no están escribiéndolas. ¿Qué? Que ellos no están escribiéndolas. No le pedí la respuesta ahí.
So did you get 0.0959, actually 96 on this?
0.096.
0.096.
Yep, that's what I got.
Perfect. So 16, based on the results of the test, can you say that there is a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance, using the level of significant 0.05?
So I believe it would be no, because the p-value is greater than the level of significance. I believe it would be that one.
Acuérdate, mami, ya. Bueno.
Is that what you guys think too?
You mean the first one, right?
Yeah. Okay. Awesome.
Mm-hmm.
All right. Okie doke. All right, Kim, do you want to read the next one?
Okay. A
Awesome.
real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual state certification. It is important that different appraisers to be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive these estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? Explain.
So I'm
I'm
pretty
saying, yeah, the third one, yes. Yes.
Yeah.
Yeah.
Sorry, I cut you off there. But
No,
yeah,
you're
I
good.
agree.
We started talking at the same time, and then I looked and I saw that you and I had the same answer.
Awesome. Okay. Very cool. All right, I'll read the next one. Now, suppose the company of the previous question wanted to use a hypotenuse test to determine whether the estimates given by 2 appraisers are different. Which of the following would be most appropriate pair of hypotenuse for each for such a test?
Third one, right?
Yeah, I believe it would be the third one too.
Yes, because the difference is not the same, right?
Mm-hmm.
Yeah.
Perfect. Okay, number 19. Suppose you create a 95% confidence interval of the mean and get those 2 numbers. You've been told to report this by saying, we are 95% confident the true mean lies between those 2, the confidence interval. Explain what does this mean?
I always get this question wrong. I'm guessing it'd be the first one. I'm not completely sure.
I think you're right with the first one. I always get it wrong as well too. So, but I think that's what it is. Kim, how do you feel about these ones?
I think it's second one. I'm not sure.
Okay.
All right. It's kind of funny because in the question before, it gave us like 5 different explanations.
Uh-huh.
Yeah. So if you get that one right, you get this one right, I guess. Hopefully. So I guess for this question, we can either move on, or if you guys want to continue to think about it, you go for it.
I just move on.
Yeah? Okay.
Yeah.
Awesome. All right, question 20. I forget whose turn it is. Kim, would you like to?
Okay. If p equals 4 divided by 5, what is the smallest value of n that satisfies the requirements for a normal distributed p hat?
So for this one, I believe the thing that you'd be using is actually, you know, the two requirements for doing a proportion test, that you have to have it like, it was like p n, so p times by n equals greater than 10, and then it was, I believe it was, n bracket 1 take away n bracket equals, greater than 10. So it's those two equations, I believe. I'll actually show you the actual equation. Might be better just to see it. Yeah, it's this one right here. And this is where I'm a little bit confused, because I know that you use both these equations to figure it out. The only thing is you do 4 divided by 5, which gives you 0.8. And I know a few times you do 10 divided by 0.8. It gives you 12.5, but I think that you're supposed to have a whole number. So you have to use the other one, which is this one right here. And then you would do 10, hold on, not that one, sorry. You'd use this one right here. And then you do n, you do 1 take away 0.8, which gives you 0.2, and then you do 10 divided by 0.2, which gives you 50. So I believe it's 50.
Okay.
Is that what you guys think it is, or?
I'm not sure, but what was the answer on your other one was 12 something, right? When you did the other equation.
Yeah, so the first equation, which is NP, it's like 12.5. The only thing is I know that's not a whole number. So I'm thinking it would be 50, just because it's supposed to, even despite, I guess you'd go with the number which is the highest number for those two equations. And I think that's how it works. I think that you're supposed to go with the highest number.
Yeah, and that would be 50, so I agree.
Yeah, okay. Awesome. All right, on to the next one. So this one, actually, I read this one, and I think it was really tricky to figure it out. But I'm sure, I think I got the right answer. We'll see.
Okay.
All right. Your little brother has a career. Actually, no, this one is the easy one. Never mind. We haven't reached the hard one yet. Okay. Your little brother has a career battling average of 0.233. You want to determine the probability that he will have a battling average over 0.250 next session, when he will be up to bat 40 times. Are the conditions met so that the sample proportion, p hat, will be approximately normal? So I believe that we would divide both the battling averages to get the p hat. And the p hat is 0.932. All right. And then with that p hat, you'd use those two equations again. There we go.
So is it the second one?
And so I'm thinking, Let me double check. So this is the, actually I'm looking, I was thinking it might be the third one, just because if you do use one of the equations, I know that actually it's a lower number.
Mm-hmm.
So I'm just gonna see if that was what I got actually. Actually, huh. I gotta figure this out first. Because we do actually have the end. So the end is taken into consideration too. Yeah, so I know that for this, if you see on my screen, this equation right here, it actually doesn't equal up to 10, greater than 10. So for this one, it actually equals up to 2.72.
Mm-hmm.
So I'm thinking it'd still be the third one. I could be incorrect. You guys could go, like, if you're confident you could be another one, you go for it for sure.
Okay.
Just because I think that it just has to be with both rules. They have to equal up to 10. But that's just my thinking.
Okay.
All right. So I guess, do you guys want to move on to the next one, or?
Yeah.
Yep, awesome. All right. And I believe, Kevin, would you like to read the next one? I think it's your turn.
Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the N equals 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places in decimal form.
So this is what I'm debating. I'm thinking that it would either be the third one or the last one. I'm pretty sure it would be the last one, though.
Oh, did I just skip the question number 22?
Oh.
I'm sorry, I read 23.
Oh, you read 23. Oh.
Yeah.
Okay, my bad. Okay, no worries. I'll read number 20. 20. Yeah, I'll read it for you. Okay. Not a problem. A geneticist takes a simple random sample of N equals 120 gamete sex cells from the tests of a dog to determine the proportion which contains the chromosomes for a developed into male. Assume the unknown true proportion of dog gametes that contain the male chromosome is 46%. The geneticist conducts a survey and calculates 0.512. Which of the following is the most correct interpretation of the statistic?
I believe this is the third one.
The third one?
Mm-hmm.
Yeah, that's I'm debating. I'm debating it as the third one or the last one, because it is basically the percentage of all of them. Because she already conducted the survey and she came up with it 51.2.
Mhm.
I'm just thinking that the last one, I don't know, I could be wrong completely, but I'm thinking it's just because it's out of the sample, a random sample of 140. So it's 51.2% of gametes in the sample have a male chromosome. So that's what I'm thinking. But you very well could be right with the third one.
I think it's the third one because isn't it? It's like you're making a blanket statement of everything. It's not just the sample when you come up with your conclusions, right?
Yeah, that's right. Actually, that does make sense. So I guess we're gonna go with the third one then. I guess all in favor.
That's what I'm
Alright.
clicking. You guys choose, I guess.
All right. I guess Kim already read the next one, so you don't have to read that again.
Okay.
Don't worry about that. So I'm thinking for this one, you would actually use an Excel sheet. Let's go to main page, courses, Excel tools. Trying to figure out percentage. Okay, cool.
Is this like a one proportion test? So it's like 320 is X.
I'm sorry. Repeat that again, Libby.
Is this like a one sample proportion test?
Yeah,
that's what we're going.
Yeah, that's what I'm thinking it is.
Okay.
Yeah. I mean, I came up with this answer. I'm just trying to figure out how did I figure out over conditions. Monopolar 35. Yeah, it's at 65 out of that software for no more. Considered study. Calculate the probability that over 65.
Yeah, I got your 0.099 for p-value.
I'm actually trying to figure out how I got that answer. How did you get that?
Yeah. I did the 320 in the X, 320 in X, 750 in N, and then the confidence level if at 0.95. The null hypotenuse I put in the 0.45. And then less than.
Less than. Okay. All right. And it was less than because fewer.
So,
There we go.
yeah. Yeah.
Wonderful. I was like, man, I did this. How can I not figure it out? Okay.
Yep. Yep. You're good.
Awesome. No, that's awesome. Way cool. So I
Okay.
guess,
24. We ready?
yep, go for it.
Suppose your test P equals 0.62 against P does not equal 6.2, and you have calculated the test statistic to be Z equals 1.334. The area to the right of Z equals 1.334. Under the standard normal density curve is 0.091. Which one of the following is the p-value of your hypotenuse test?
All right. So I'll be honest with you guys. I remember doing a question like this beforehand, and I did it a certain way, so I just kind of copied what I did last time. So I don't even know if it's right or not. But I'll show you what I did. Maybe you guys can make sense of it. Or if you guys know what to do, just let me know. But what I did is I just inputted basically the z-score, I believe. And you see how like this is 0.091?
Mm-hmm.
So I don't know why I did this, but I did both the sides and got the middle. I don't know how that makes sense, but it's okay. But that's the answer I came up with. So I don't even know if it's right or not. Hopefully it is. I don't know how to make sense of it either, so.
I'm not sure yours makes sense to me. You know what I mean? And you're like, yep, sounds great with that, but I have no idea.
Yeah, I actually have no idea either.
Kim, any
Yeah,
ideas?
I'm good with that too.
Yeah, okay.
Yeah.
Well, we'll see if it's right. All right. Question number 25. All right, I can go for it. Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean. So this is the one that is a little bit tricky. Suppose you are a dog breeder and you want to use the confidence interval to estimate the true mean fertility level, not fertilize, of the purebred cocker spaniels. It is known that the distribution of fertility levels, cocker spaniels, is normal. How many measures must you have in order to be sure the sample distribution of X is normal? Okay, there you go. So the reason this one actually is, I think it's a tricky question because it said it's known that the distribution of the fertility levels of cocker spaniels, I don't even know how you're pronouncing that, right? But it is normal. So it says that it's known and it is normal, right? So pretty much I'm thinking that would be any N will do, just because you know it's going to be normal no matter what.
Yeah.
So that's what I'm thinking, and it's a trick question. But hopefully it's right.
Yeah, I think I agree with you.
Yeah? Okay. Perfect. What do you think, Wendy? Is that good?
Yep, that's good.
All right. All right. I believe, Kim, is it whose turn? Sorry, I don't know. I forget.
It's my turn.
Okay.
A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this hypothesis test? Why?
Okay. There we go.
I think it's the last one.
Yeah, I believe it is too. Just because I think I remember doing this. I remember that one of them, it was actually less. So it has to do with both of them, I believe.
Yeah, and I think they both have to be like number 2 is right, but they are both over 10 if you just do n times p hat, but in the other equation, they don't both make that requirement, and I think they both have to meet both requirements, right?
Yep, that's what I believe too.
Perfect.
All right.
Okay, 27. A study was conducted to measure the effectiveness of a diet program that claimed to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this?
I'm thinking it would be the second one, just because when they are selecting the participants, it's the same person, right? And they're doing 2 different scores, right? So I believe it would be the second one, just because they're using a paired a sampling method.
Yeah, does that mean mean of difference does not equal 0?
Yeah, exactly.
The D stands for, okay.
Actually, I'm going to check that out. I'm pretty sure that's right. Let me see. Let's go to one proportion, not one proportion. Let's go to paired. There we go. Yep, that would be it. It would be, yep, 50-0. That's right. All right. I believe it's my turn, correct? Terrible at this.
Yeah.
Anyways, oh yeah, I'll go for it. Weight Watchers want to predict how much weight a client would lose if they follow a prescribed exercise program. In addition to their diet program, volunteers were randomly divided into two groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, they use a linear regression with a percent compliance with the exercise program as the explanatory variable, and pounds lost in pounds. My gosh, I'm just doing terrible. Lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean? Residual. So I'm thinking it would be the second one.
Yes.
Yeah? Okay.
There.
Alright. And I'm believing the reason why is because they're going off of first, there was a predicted weight loss that they're going off of.
Okay.
So his actual weight loss is 5.5 higher than the predicted weight loss. So meaning that he had a weight loss beforehand and they scaled it out, but then they've realized that his weight loss was 5.5 pounds higher. So that's why I'm thinking why it's that. So hopefully it's true.
Yeah.
Okay.
Yeah.
All right. So the next one is similar. It says, for the study in the previous question, the PB of the regression line was 5 pounds. Interpret the statistic. So I put it for the last one. For the third one. Because it just made sense that by 1%, right? Because they're going by percents, right? Because they're using a percent compliance. So for every 1%, it would increase by 5 pounds, as indicated right here. So it says that the line of regression was 5 pounds. Interpret the statistic. I believe just because every time that you go up by 1%, so do you go up by 5 pounds. So for the slope. So that's what I'm thinking would be the right answer.
Yeah, that makes sense to me.
Yeah. All right. Wonderful. All right. So this one, we did this question beforehand. So that's why I remember. So I believe we selected all three of these, and you were right, Kim. Wendy. You were right, because I remember we did this the first time, and I was like, yeah. I was thinking, you know what? You're supposed to do the X. I think I chose one of these guys, and I got completely wrong. It's just three of these. Yeah.
Those three. Okay.
Yeah. Just those three.
Perfect. Yeah, that was last time.
Yeah, that's why I remembered.
Oh, I love to see this next line. Use the following information to answer the next 12 questions. That means we can think about the same data.
Dude, yeah. But the good things are almost done.
Yes, that is true.
All right. Kim, if you want me to read, I can go for it. It's up to you.
I'll do it.
Yeah, okay.
Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Ellie Heinrich, a BYU Idaho student, wanted to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 non-stop midweek flights 90 days in advance and then found the lowest published price for the same destination again 14 days in advance. The prices are given in the file. Direct Coast Excel noticed that for some destinations, flights were not available. Compute the sample correlation coefficient of the price of tickets 14 days before compared with the price of tickets 19 days before. Give your answer accurate to 3 decimals.
Okay.
So 14 goes in column 1, correct? 14 days before is in column 1, and 19 days is in column B.
So yeah, that's the one thing I was thinking of, because if you look at the bottom sentence of 31, I think it's actually supposed to be 90 because 90 is independent.
No, you're right.
Yeah, that's the bummer. We're gonna have to know this when we're doing the exam, which is gonna be intense. Because the reason why I said that is because 14 days before compared with the price of the tickets 90 days before. So it's just basically, it's the 14 days is independent of the 90 days. So that's why I came with that reasoning. I think in the sentence it gives a better explanation though. No, I think coefficient of the price ticket states before compared with the prices. Oh, let's see. I think want to predict the price of tickets 14 days before based on the prices of tickets. Yeah, so yeah, 90 days is basically independent because inside that sentence, we want to predict the prices of the tickets that's all and capitalized. Want to predict the prices of tickets 14 days before a flight based on the prices of 90 days. So 90 days is actually independent and 14 days is dependent on the 90 days. There you go.
Okay, so I need to swap them.
Yeah. Okay, here we go. But I know that I'm definitely, when we're studying for the exam, I'm gonna have to review over that because that can be very confusing.
I will be writing in my notes which y equals the independent one, x equals the
Yeah, agreed. Okay, there we go. All right, guys, we're almost done. Still got 14 more. Oh, sorry, 16. All right. Let's see. So yeah, for that one, calculate, compare tickets, prices before, sample correlation coefficient. I believe it's the R. So that would be the R right there. And did you guys get 0.780 for that one?
I'm still adding in data. My Excel is deciding to crash at this moment.
Yep, not a problem. As you notice, for me, it takes me forever to close only windows, so no worries.
Here we go again. It's gonna get there.
Yep, not a problem. No worries.
.780.
Yep.
Perfect.
Awesome. And then all the other ones should be pretty. All right. Okay, for the next one, create a scatter plot using these two variables, which is nice because it's already there. Use the pattern scatter plot referring to the correlation coefficient. Select the answer that best describes the data illustrated in the scatter plot. So I believe it'd be the second one. Linear with a fairly strong positive association.
Yeah.
All right. You guys agree with that?
Yep.
I agree. Yeah.
Awesome.
I'm sorry. Yep.
Okay, cool. All right. So the next one, I forget whose turn it is. I'm sorry.
I haven't read for a while, so I'll read the next one.
Sure, you go for it.
For the next two questions, compute the y-intercept with and the slope of the linear regression used to predict the price of the tickets 14 days before the flight began. 14 days before the flight based on the price of the tickets listed 90 days before the flight. What is the y-intercept?
So that should be pretty easy. It would be 115.64. You guys saw how we got that, right?
Mm-hmm.
Yep.
Mhm.
All right. What is the slope? The slope would be a 0.627. And then for the next one, okay, now we actually have to do some calculations. So for the next one, you guys remember the equation for the slope, right? It's just the y. So it'd be the y-intercept plus the so it'd be the y-intercept plus the slope, which is 0.627 times by, I think it's 200, I believe. Yep. And that should give you, 241.04. Did you guys got that right too, right? Or it's all good. I can actually even show you the equation if you want me to. It might make it easier for you.
Yeah, remind me of the equation one more time.
Yep, not a problem. All right, let's go back here. Let's go to, I believe it's 24? No, it's 23 actually. Let's go all the way down. There it is right there. So it'd be y equals b0 plus b1 and x. And if we go back here on the Excel sheet, sorry, I kind of blocked that off. I'm going to open it up right here. And that's the wrong Excel sheet. And we're going to open up the right one. We're going to go right here. There we go. Awesome. There we go. So then, and is this the wrong one again? Yes, it is.
Uh-huh.
All right. Round 2. Or round 4, actually. Here we go. This is the right one. So then it would be basically your y-intercept, which is, you see how it's b0 right there?
Uh-huh.
And then it would be B1 right here too. So you'd basically do B0 plus B1 times by x right there. And then the x in this question, if I go back to the question, the x that they're trying to want us to figure out is actually the 200 right here.
Okay.
So yeah, the flight costing 200. So then you just would put all that information into that equation right there, and you should come up with this number. So let me know if you guys, if it works out. If it doesn't, just let me know.
Did you say times by 200 at the end?
Yeah, so times by 200, yeah. Just because.
Okay. So I
yeah.
got like $23,000. 23,000.
Oh, nice.
So I'll go one more time, make sure I did everything right.
Yep, no worries. If I go back here, there we go. So yeah, you just want to be, let's see, if I can do this, let's see, equals.
Oh, I see what I did. Never
this.
mind. I gotcha. I did the 115 something. I did the B0 plus the B1, then times by, not the B1 times 200 and then plus the other.
Oh,
Does that make
you
sense?
see. Yeah,
Okay.
that makes sense. Yeah, not a problem. No worries.
I knew there was something whacked out about that. That makes, well, okay.
Do that plus that times by, wow, I put an 8. Times by, and I believe it was 200, yeah.
241.04.
Yep, that would be the answer right there.
Perfect.
Actually, hold up. Excel actually did it differently for me.
Oh.
I'm pretty sure I had the right answer, though. I did in the calculator. So I'm going with that. I'm going with this one. I'm pretty positive that. I think that Excel might be a little bit more accurate, though.
Oh, it probably is.
I'm hoping that they take that in consideration. That, you know, if you're doing it through a calculator, it's not as accurate.
Mm-hmm. I'm assuming they do.
Yeah, I'm assuming they do too. I'm just gonna do it again, just to see. Yeah, that's what I got. I'm hoping that they don't. Well, if we get it wrong, then you know what happened. There you go. Let's dip through Excel.
Okay, wait. It says to the 1 decimal place. Give your answer according to 1 decimal place.
Okay.
So
I'm gonna try Excel again. Maybe I inputted it wrong. No, I think that's right. I did both of these times by 200.
okay.
So it's up to you guys. You can either go with what Excel stated, or because that would make it 241. But it says 1 decimal place, right?
Yeah, so it's 241.0.
Yeah, which makes no sense.
Mm-hmm. Mm-hmm.
I'm thinking that the calculator, I'm like, it may be okay, but
Yeah.
up to you guys.
I'm putting 241.0 because that's kind of rounding to the 1 decimal place of both Excel and our calculations.
There you go. Hey, I guess that works out. Yeah, that's true. I'll leave it up to you guys.
Okay.
All right. Okay, so what is the lower bound for your convenience interval? At a 95% confidence interval for the slope. So that should be right there. And I'm looking at paired right now. Great. There we go. Yeah, so it would be 0.518 for the, I believe it's the lower, and then the upper would be 0.735. And I know that, and the only reason I know that is because when you're trying to find the convenience intervals, they always go by the slope. Confidence interval, sorry. So for the upper bound and lower bound, that's what they're trying to look for. So when they're asking you for the confidence interval for lower bound and upper bound, it would always be those two right there. From what I've read. So.
Perfect.
Because that can be very confusing because you can see there's both of them. You're like, what's going on?
Mm-hmm.
And then the margin of error, and you guys know how to get the margin of error, right? I can show you guys if you really want me to. The way that you'd figure it out, I believe, it would just be the slope right here. So it'd be basically the slope take away from the confidence interval, the upper bound and the lower bound. And then you should get 0.108. Let me know if that makes sense.
Yeah.
Yeah. Okay.
And then do you divide it by 2?
Yeah, that is a good question.
Or is that I have a weird equation that it's those two minus each other divided by 2. And I should have labeled it when I did it, but I did not.
No worries. I'm pretty sure that you just take away from it, but I know there's another way to figure it out with another equation. I mean, I've always just done it that way. Like even when we used to just do it for like the t values and the z score,
Okay.
I've always just done it that way. It has came up to be true. So
if you sum the 2 and divide it by 2, you will get the right margin of error.
Oh, so if you add both the confidence intervals.
Yeah, and divide it by 2.
Okay. I'll
You're
test
right.
that out. Thank you, good sir.
Because I believe, or I don't know.
I think you subtract them or add them?
Yeah, you subtract it and divide it by 2. Yeah.
Okay, subtract and divide by 2. Okay.
You have to subtract and divide it by 2.
Perfect.
Oh, so you'd subtract one interval by another interval, and then you divide it by 2.
Mm-hmm.
Okay, I'm gonna test that out. Yep, that is true. Can you come up with the same answer?
Okay.
Thank you there, Silent. Kabam. You came in the right moment. All right, my friend. So if you're wondering, so you know where we are in the quiz, right? We're just on question number 38.
Yeah.
Okay, awesome. Okay.
Little late.
No worries, man.
I've been hearing, but not much.
Okay. And I believe, I forget whose turn it is. I'm sorry, guys. I've just been reading the whole time. So.
I got here. For the next 4 questions, conduct a hypotenuse test to determine if the slope of the true linear regression line is not equal to 0. So 39, choose the correct null and alternative hypotenuse for this analyzation.
All right. So I believe it would be the last one. Yep, and it's even open right there. You can blatantly see. There you go.
Perfect.
Yeah, so you know that is for sure, right?
I believe so. Who's that one? What is the value of the test?
What is the value of the test statistic? So I believe you'd still go out off of the slope. And the test statistic would be 11.510.
Yeah.
Awesome. All right. And what is the p-value?
0.000.
Yep, that's right, because you can't even put that in. Yeah, because it in reality, it's 4.246 e. I mean, to the exponent of negative 19. So yeah, it would be 0.000. All right. Next question. Actually, Simon, would you like to read the next one, my man?
Yeah.
Awesome.
What decisions do you make based on the p-value and the level of significance? Alpha equals 0.05, and thus, what do you conclude? To reject the null hypothesis? Reject. There is sufficient evidence to suggest that the slope of the true linear regressions line does not equals to 0. We conclude that there is a linear relationship between 14 days ticket price and 90-day ticket price. C.
Yep. I believe it would be true. That would be the right one. All right. Okie doke. 43.
You want me to read it again?
Sure, bud. You go for it.
Okay. In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the United States to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care programs in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the programs and birth weight data is recorded. Which hypothesis test will be most appropriate for this study? Independent sample test?
Yeah, I'm thinking it would be the one sample t-test. Because we're not going off of proportions or anything like that, and it's not a ANOVA because we're only looking at the birth weights of babies born in the United States, right? To mothers living in poverty. So yeah, I believe it would be one sample t-test.
Why not independent sample test, t-test?
Oh, you said it's independent sample t-test.
Yeah.
Okay.
The two variables, like.
Is there two? I think is there only one variable though? Just the birth weight?
I believe that's, I think that there's only one variable. Birth weights of babies born in the United States to mothers living in poverty is approximately 2,800 grams. So yeah, I believe it would be one sample t-test because there's one variable.
Hey, but is it a Z because we know the? Is it the first one sample because we know the mean?
Yeah.
Okay.
That time I'm kind of skeptical because I know that I've done a question like that before, and it's like, despite that we may know the mean, it still ends up. I don't know. You guys choose which one you think's best.
Okay.
Yeah. Because it could be the one sample z-test because we are given the mean.
Yeah.
All right.
Question 44. Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. What hypotenuse test would be most accurate for this task?
So this one would definitely be one sample z-test. Just because we know the standard deviation.
But we don't know the mean.
That is the thing. It's the same thing for the
and isn't it like it was described like mean is known and mean is not known, right? When we did those. So it doesn't, it's not that the standard deviation, but it was that the mean was known and the mean was unknown.
So yeah, you mean for the first one, right, Wendy?
No, for when we learned the difference between a Z and a t-test. Wasn't it just the mean?
That is a good question. I know that actually from one of the professor's lectures, he stated that if you know the standard deviation, it would always be a sample z-test. So that's pretty much what I'm just basing my answer off of.
Okay.
But that's a good question though, because if we go back, that's what I'm trying to debate, because I know that we do. Like, do we know the mean for one sample z-test?
Yeah.
Or you do, right?
Yeah. And then the z-test you don't. So like on the question before this, I'm putting the one sample z-test because we know the mean, and on this one I'm putting one sample t-test because we don't know the mean, but we do know the standard deviation.
Yeah.
So
yeah. I just wish that they had like those. I remember there was questions that had like, a z-test without a mean, and then there was a z-test without standard deviation. I know there was like two things. I wish that they had this for this question. That's what makes it so. Yeah.
Yeah. Yeah. No, that makes sense.
But I'm thinking it'd be one sample z-test. But if you think it's one sample t-test, you go for it.
Okay.
All right. So the next one is pretty easy, I believe. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would most appropriate in this situation? So we're only looking at one percentage, which is 45 years old is more. So we're looking at Walmart employees in Nevada, 3%. So this would be a test of one proportion.
Yeah.
All right. And then this one, the next one. Kim, did you want to read it?
Okay.
Yeah, okay. Awesome.
Mary Constler conducted a study of couples, categorizing each of the couples as communicative or non-communicative, among other things. The counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in a separation or divorce. Which hypothesis test would be most appropriate for this study?
I'm thinking it'd be a test of two proportions.
Yeah.
Yeah.
That's what I think, because we don't have a number.
Yeah.
Like exactly. It's not. Yeah.
All right. 47. I'll finish this off. Okay. A business market firm specializes in radio advertising. They hope to show there is a linear relationship between, so that just is a giveaway, a relationship between sales and amount of money a client invests in radio advertising. Which procedure would be most appropriate for addressing this question? So it'd be linear regression, right?
Mm-hmm.
Yeah. Well, guys, we have finished it. That was an intense meeting.
Yeah. It was the longest one I think we've had. Way to finish her out strong, right?
It took like 2 hours.
Yeah, jeez. Wow.
Yeah.
But I guess other than that, I guess this is the final meeting. That's intense.
Yeah.
But I other than that, guys, do you have any other questions regarding the quiz, or you're gonna try to figure it? I know we probably got some answers wrong, but hopefully not. I don't know. But anything else you guys would like to discuss about, or is that it?
So I'm gonna upload the presentation on Saturday. So if you guys find anything specific things, then just tell me.
Yeah, not a problem.
Yeah, I will for sure.
Awesome. Well, there, guys, I just want to bid you guys farewell. It's been an awesome getting to know you all.
Mm-hmm.
Yeah.
Best of luck.
What was that?
I said best of luck on the final and in your next courses.
Oh yeah, thank you. To you guys too.
Oh, thank
I hope
you.
when you submit this through, it works out. There's a lot to study, man. I'm gonna study there's so much I'm gonna study right now. Crazy.
Yeah. Good thing we have till next Wednesday, right?
Yep, that's right.
Take my
Man.
own finals.
Nice. Yeah, same with me too. I was so surprised that it was on Wednesday. I was like, dang it, another Wednesday. Great. Because I was thinking it'd be at the end of the week, but hey, what can you do?
Next week.
Yeah.
Yep.
Well,
Alrighty.
guys, you take care.
See ya.
Hey, take care. Good luck on your exams. Peace.
Bye-bye.
Okay.
Bye-bye.
Bye.
And Kim, I'll let you know for sure if I find
Okay,
anything.
thank you.
No worries. See you later. Well, you take care. Actually, Stein, did you have any questions regarding anything, man? I know that you came in a little bit later.
Oh, yeah.
Okay. So I can help you out a little bit, my man. If you'd like me to. I just want to leave you on the blue.
Yeah.
Because I think you came in when we were just finished the answers. I can tell you what we got. You can see my screen still, right?
Yeah.
Okay. So what we did, for starting from the beginning, you can kind of see question 2 right there, right?
Yeah.
So we got the last one right there. So it'd just be the number of people in a randomly selected classroom on campus.
Yeah.
All
I have
right.
that.
Awesome. And then 3 we got, well, I was pretty sure it was this one. An observed study because the students had no control over the price of the individual cereals. So that's what I got. I know that, I think Wendy thought that it was going to be this one right here, which is observational study because the students had no control over the, but I'm pretty sure it might be the second one. That's just me. So it's either this one or that one.
Okay.
The first one or the second one. This one, number 4, I believe, yeah, we got the mean will stay the same. So that's what we got for basically number 4. And then for 5, and let me know if I'm going too fast, man.
It's okay.
And then for 5, I got 2.5. So that would be for question number 5.
How'd you get that? I couldn't.
Oh yeah, no worries.
I couldn't. Like in the previous quiz, like that was due to Wednesday. This Wednesday, there was a kind of the same question like that, and I couldn't get the right answer.
Not a problem. I'm gonna actually show you how we came up with that. And I actually had to look up images online to kind of get a better explanation. So let's go right to this one right here. Actually, this one. So you see how it says 1 standard deviation, 2 standard deviation, 3 standard deviations? So this one actually is good. So what you're going to be doing is that you're going to be basically putting the mean in the middle. So I'm actually going to minimize this right here. And let's go to put that at the side. Where's the questions right there? So what you'll be doing is that you see how there, it says it has a mean of 70 right there? So what you'd be doing is that you'd put the 70 minutes right in the middle right there. And so this is actually the, sorry, my bad. This is the picture right here we're looking at. I want to get a better view of it. Oh, wow. Didn't. Goodbye. So, wow, the picture's bad. I'll have to look for a bigger picture. There you go. That's a better picture. Now you can see the percentages, right? 99.7, 95, 90. Okay, there you go. So what we were doing is that for this one, how you determine it is that you would put the 70 right at the bottom right there. So it's right in the mid. So this is the mean right in the middle. So you put the mean right there. And then what you want to do is you want to subtract or you want to add standard deviations. So for instance, you see how we have 70. So when you're going 1 standard deviation, which this one gives you a better explanation, but I can't wind it up. Maybe, can I make a bigger image? I'm going to actually copy this.
No,
Copy
but
image.
okay, it's okay. If it's like that,
Yeah.
I think
Okay.
that's okay.
Good. So what you do is that you have 70 right in the middle, and we want to know. So what was the question again? How we got this? 70 minutes standard deviation. We're approximately students. We'll keep in 50 minutes, right? So if you keep on going down one standard deviation, a second standard deviation, right? You go to the mark of 95 right here, right?
Mm-hmm.
So what you want to do is that you see how there's a percentage there. You actually want to divide 95 by 2. And that will give you 47.5. And remember that in total, this whole anomaly, I guess this whole, I'm completely forget. You know the hill?
Yeah.
Complete. You know the terminology for it.
Yeah.
So the hill. I'm terrible. I can't remember the name, the terminology for it. Anyways, you divide 95 by 2, you'd get 47.5, and then you would actually take away 50 because you want to determine how much is basically here in this portion right here, right?
Yeah.
So basically it's saying under 50 minutes. So under 50, hold up, I need to think about this a little bit more. Exams, approximately what percentage of students will complete their exams under 50 minutes? Yeah. Yeah, so you want to figure out under 50 minutes right here, this proportion.
Yeah.
So then you take.
I got it. I guess in the quiz I did it right actually, but I guessed the answer, but I wasn't sure. Like
Nice.
I was guessing right. That makes sense. Like
good. All right. Yeah, that's pretty much it, man. That's all you do.
Yeah. Okay.
The only reason I'm really familiar.
I thought
with
that was
this,
a formula or something like you get that to that number.
Yeah. I mean, me too. Actually, the only reason I actually got this answer, and is because one of my other classes actually covers this.
Okay.
It gives a big.
Yeah, it's okay.
Yeah, it gives me more of an explanation, but yeah, that's it. You're good.
Yeah, okay.
Other than that, so this one was actually a little bit harder to calculate. But so this one we got 146.8. So that's what we got for that answer.
Okay.
Did you want me to explain how we got that, or are you good?
No, it's okay. Let's move on.
Yeah.
I have two quizzes.
Okay, no worries. All right, so 7, we got right skewed. Then for number 8, wow, my scrolling is messing up. Anyways, we got 2.236, which is basically for number 8. And then for number 9, we got 0.
Hold on, 2 point?
Yep, so we got 2.236.
Okay.
Yep, and then for number 9, we got 0.991.
Okay.
And then for 10, we actually got the probability of a type 1 error.
Yeah. The following describe the notions of significance. Yeah.
Yep. Okay. And then for this one, we actually kind of were guessing, to be completely honest. Actually, no, we weren't.
I hate questions.
Yeah, I don't like these questions. We're guessing is that, we kind of were guessing. So I was thinking it would be the 2 last ones and then the first one. So that's pretty much my assumption. I'm not completely sure if it's right or not, but that's pretty much what I was thinking.
I don't know. Whatever that type of question,
yeah, I know it's hard.
It's kind of confusing to me.
It is. I mean, like, we are 90% confident. I understand that one, that the true mean of height of adults in the United States is somewhere between. Yeah, that makes sense. But the other ones, I don't know. Yeah, it's hard.
Wow.
For question 12, we got, yes, the distribution of sample means is normal because the data are normal.
Okay.
And then for question 13, we got 0.019. And then 14, we got dependent sampling. He needs to select couples from his sample. So whether a particular wife is concluded depends on whether her husband is included. So that's the one that we picked for that one.
Yeah.
And then for 15, we got 0.096.
Okay.
And then 16, we got the first one. No, because the p-value is greater than the level of significance. And then 17, we got the third one. Yes, the distribution of mean difference is normal because the data have been determined to be normal. So it's similar to the last one. And then 18, we got the third one. Because this one's just determining something that's paired.
Yeah, makes sense.
And then this one, yeah, this is another one that we weren't completely sure about. So I chose the first one.
Here we go again.
What was that?
Again, 99%.
Yeah. Yeah, I have no idea. I'll be completely honest. And we're going down again. And then we got 50 for actually 20. It's 5-0. And then I put no, yeah, so it would be the third one. No, p-hat can only be normal if the sample data are normally distributed. So that's what we got for 21.
Yeah, at that point I was here. And
oh, you're right here at that point.
yeah, I was.
Oh, okay.
I arrived home by that time and I connected. I don't know if you noticed that I got disconnected and again connected. I disconnect from my cell phone and then I connect through the.
Okay. Well, did you need? I can still go over the next questions if you want, man. It's up to you.
No, it's okay. It's okay.
Okay. I mean, like.
It's okay for me.
Yeah. I mean, but hey.
I wonder if you don't have to meet again, like just with the. I was hearing, but I couldn't see the presentation, the PowerPoint.
Yeah. So what
I was hearing that you were, oh, this is a great job, la la la. But I wondered if you need, like, if we need to meet or just we're going to just send her like anything.
So
or we're gonna use that, or just send an email with the feedback.
Yeah, that's exactly it. I mean, Kim just basically stated that she would wanted us just to kind of look over it, just to see if there's anything that needs any changes.
Mm-hmm.
And she actually did it all. I'm very surprised. I mean, I initially thought that we were just going to talk about it today, but she completed everything. So that's it.
Yeah, I wonder. I don't know. Sorry, but. Are you okay with that template?
You know, I don't think that will be tested on how good the template looks. I'm pretty sure it should be okay. I mean, I understand what you're saying. If you want to, you can actually suggest that to Kim, and she can actually change it. Because I was thinking that too. Because I was just like, you know, there's a different type of template or anything. But I believe that, I guess since it's through Google Chrome, they don't have much selection.
Yeah, it seems to me that Clinton just created that, but I don't think he go through like looking for like, you know, the template like, you know, like could meet, like looks like the study we're doing, like it would be if we could put something related to school, like
yeah.
You know, like to illustrate a little bit about what we're doing a study about, like, or a student eating or something, I don't know, like in a school, in a food court or something like that. I just wonder, like, we can go through and make some template like related to the study we're doing.
Yeah, I agree with you. I mean, that's a good idea because we are doing it on meals, right?
Yeah, we go something a breach at the end, and then I wondered
Yeah, has
Good.
nothing to do with our.
From California, or I don't know, the Golden Gate, probably. But I don't know.
That's a
Food,
good point,
Golden
man.
Gate. I don't know. Just wonder that.
No, that makes sense, man. You
My
know
boss,
what?
in my job, my boss would tell me, "What the heck you presented?"
Yeah, you'd be like, yeah, it's sort of based on meals with people eating it on bridges.
Yeah.
I agree, but yeah, I know that we don't have much selection on the PowerPoint, but that's something you can definitely suggest to Kim if you'd like to, man. That
Yeah,
would
I will. I
be
would.
great.
I will type a mail, and
Sure.
and then I will just make a comment.
And you do have her email address, right? Or
I think in a I think I and she replies me when I. Do you remember the time when I sent my assignment,
yeah,
one of the
that's
projects? She replies saying, "Oh, I like it," and I don't know, like. I don't know.
awesome.
I can go through and I will find like her reply, and then I can reply her back. So yeah.
I mean, I'm definitely gonna look over it too, just to make sure everything makes sense and everything.
Mm-hmm.
So definitely, I'll look it over also. Let's double check too.
Well, that's all what I have. I was in the car. I didn't turn on the microphone because my kid was there and they were making a lot of noise. So
No worries, man.
like the microphone with my kids.
Hey, they're kids, man. You can't help it.
Probably would kill me. You all.
Well, my friend, I believe that's it, man.
Yeah.
Other than that, we're gonna do our exam and it's gonna
I
be
just have
intense.
a little question.
Yep.
Do you play video games?
Me, I do.
Ah, I knew it.
How did you know?
Because I do.
Yeah. Oh yeah, I play occasionally. Yeah, when I have spare time, I play like Fortnite, different things like that. Yeah.
Yeah.
Man, how did you know that though? That's intense. Good job.
Just by hearing you, the comments you make, the way you say things, I noticed. This guy play video games.
Hey, well, thanks, bud. I appreciate it.
But it's okay. That's not bad.
Yeah, I have my social skills from playing video games. That's for sure. Some of them, but some of them with sports too. Like pass the ball, dribble. I'm actually okay at basketball. The only thing is I work on my 3-point shot. I'm not very good at it. Layups, okay, decent. Got to work on basketball though.
Yeah, I played a lot, but since I have kids,
Yeah.
things got complicated.
No, I have fun with my friends too. As soon as they got kids, it's a little harder. But when they become teenagers, my friend, that's when you get to play.
Yeah.
So you get to go to scouts, young men's. That's awesome. Yeah. Hey, my friend.
Jeremy, thank you for having me in the group and for all the support. I'm so grateful, and hopefully, we could be friends beyond this class.
Yeah, for sure, man. I would love that. That would be great, man. Well, you have my email address, and you can either research me on Facebook also. Like, I have your last name too, so you can always add me there too, my friend. I'll do the same with you.
Yeah, I will send you a. Jeremy, what's your last name?
So it's Rose.
Oh yeah, it's true. Rose. Yeah.
Yep. Rose. So I believe actually, yeah, like you have all the if you go actually on the content, it has, I believe in the beginning, the first day of class, you can see everybody's last name.
Okay.
So you'll be able to see everybody. But no, man, it was great, man. Having you guys as a group was awesome.
Yeah.
It was fun. It was a lot of fun. You guys supported us all, and we all were able to contribute for everything. So it was fantastic.
Yeah. Thank you. So I will probably send you a notification a friend notification or request. I don't know.
Yeah, for sure, man. That'd be awesome. I'll do the same with you too.
So, well, let's move on. Like, should be the last day for us to submit everything?
So that is a good question. I did actually take a look. Let me check again. I'm actually on this. Man, I have so many windows open right now. Because I think it actually is due next week, I believe. That's something I did see. But I'm not completely sure about, because he said it in his announcements that it would be due on the 14th week, which is the exam, which is that time.
Okay. No, just okay. By the way, I will work to do everything before or just on Saturday, I mean. And I want to have a vacation week because I will continue next semester. So, and the semester started right away. The next
Yeah, I know.
Because we won't have any vacation or. So I would like to do everything as soon as possible in order to have a free time, a little bit.
Oh, you mean with the project? Yeah. You know, I wouldn't worry about it too much, my friend. I mean, I think like I'll check out the information. And you can email her regarding putting some pictures in, and I'll just follow up to make sure everything is all organized and everything. I'm sure, but you don't worry about anything associated with the project. I mean, you can add like, I think that if you're going on vacation, you could like either text or you could email us. But I think we have a pretty good hand on it, on the project.
Yeah, I promised that to my family because this semester I was taking 3 classes: finance, statistics, and Excel for business. And I'm driving crazy.
Yeah, I can imagine, man. That's a lot.
Well, yeah. So I've been sacrificing my family's time and everything. So, and
yeah,
they deserve like we go somewhere.
Yeah, it's intense, man. It's hard. I mean, like I know a lot of my friends, they're going to school too at the same time as they're going to, as they have kids and a family. I mean, I'm married, which makes it a little bit easier. I haven't had kids quite yet. Eventually, but yeah, I could imagine.
Yeah.
Yeah, so I just looked it up. We will have a final exam and submit the PowerPoint presentation during the conclusion week, the 14th. So we still have another week to do it.
Yeah.
So, which is good. That's great.
Got a question.
Mm-hmm.
Did you serve a mission?
Me, I did. Yeah, I did.
Where?
I served in British Columbia. So I didn't leave Canada, but I served in a different province. That's all.
Okay. So are you Canadian?
Me, I am. Yeah. Yep.
Oh, sweet.
Yeah, man.
My family and we would like to move to Canada.
Yeah, Canada, it's a nice place. Where are you from, though, Stylen?
I'm from Dominican Republic.
Dude, it's beautiful over there, though.
Yeah, it's very hot right now. It's raining. Pretty hot.
Yeah, but I mean, you'll probably love Canada. The only thing is that it gets pretty cold up here.
Yeah, I know that.
Yeah, it's real cold.
Yeah.
But hey, I love the Dominican too. I've never been there before, but I've seen the weather. It's fantastic.
Yeah.
I mean, you get your rain sometimes, but overall the temperature is pretty high.
Are you for what province are you?
Me, I'm actually in Ontario.
Ontario. Actually, I'm right now applying for a visitor visa. So if we got the visa, probably I will contact you. Maybe I can meet you in person.
Yeah, man, that'd be fantastic.
Yeah,
that'd be great. Yeah, man, if you ever decide to go to Ontario, Ontario right now though, the prices for homes are insane though. That's the only thing. It's crazy.
Yeah.
But yeah.
I would like to go to Niagara Falls, and I don't know what else.
Oh, there's tons, man. You could go to Niagara Falls. You could go to the CN Tower. You could go to Toronto. They have a bunch of restaurants down there. You could go even to, there's actually a really cool, there's Wonderland. Wonderland, it's a convenience park. It's one of the biggest convenience park in the world. It's pretty big. So you can go there. They have Dave and Buster's. They have a whole bunch of stuff that you would definitely love it for sure. Man.
Wow.
Man,
Sweet.
but,
Yeah, hopefully if I got the visa, I will contact you. Hey, we're almost there.
That's right, man. I'd love to. I'll definitely add you on Facebook.
Well,
Yeah.
we will continue talking later.
For sure, man.
Yeah. Thank you for everything.
Hey, not a problem, my friend. And good luck on your exams. I hope everything works out.
Yeah. Thank you.
Hey, take care, bro.
Bye bye.
Bye.